Alright, let's look at the odd problems that are going to match up in the same way with your WebAssign questions. So they want to come up with two numbers whose sum is 23 and whose product is a maximum. So they ask you to set up a chart and check. And it looks like 11 and 12 would be the right answer. But if you let x and y be your two numbers and they add up to 23, then you can say y equals 23 minus x. And you can plug that in for y, and now you got a formula in terms of x only, which is the product. And when you take the first derivative and set it equal to 0, you get 11 and a half. And you get 11 and a half for y as well. So 11.5 is your actual best answer. Number 3, two numbers whose product is 100 and whose sum is minimum. So x times y equals 100, or y equals 100 over x. And you plug that in for y. Now you got it in terms of only x, and you can take the derivative and write it as one fraction. Now you set it equal to 0, and you get critical numbers of 10 or minus 10, but you don't consider the minus 10. You're only dealing with positive numbers here. And when you check intervals on either side with this, you get negative plus, negative positive, which means it's a absolute min. So x equals 10, plug it back in here, and you can find that y also equals 10. Number 5, what's the maximum vertical distance between this line and this line here and the parabola? And they limit you between minus 1 and 2, and so you're looking at some point right about here. So your vertical distance v is the distance between the y-coordinate x plus 2 and the x-coordinate x squared, the difference between those. So you take the derivative, set equals 0, and you get 1/2, and you check between minus 1 and 2, and you find that the absolute max is when x equals 1/2. So x equals 1/2, and the vertical distance v is 9/4 when x equals 1/2. Find dimensions of a rectangle with perimeter 100 whose area is as large as possible. So perimeter rectangle is 2L plus 2W equals 100. You can solve for W this way and plug it into here. Now you've got area in terms of only L. Take the derivative, set it equals 0, and you get 25, and you find that 25 is a length that gives you a maximum, and you find that W has to be 25 as well. Number 9, they talk about a yield of a crop, and they give you this formula here where K is a constant and Y is in terms of N. So when you take this guy and you take the first derivative and set it equal to 0, you get critical numbers of just, you get minus 1 here and positive 1 there, but N has to be greater than 0, so you exclude the minus 1. And between 0 to positive infinity, you've got one critical number, and it goes plus minus, so that means it's the absolute max when N equals 1. And when N equals 1, your yield ends up reducing down to 1/2 K when N equals 1. On this one, you've got a 4 different regions that are all blocked off by these fences, and you got 1, 2, 3, 4, 5 of this length and 2 of the other. And so when you look at that, you got 5 x's plus 2 y's adds up to the total fence, and we know x times y is the area. So you solve one of them for y and plug it in and take the first derivative. It gives you a critical number of 75, and you find 75 is your absolute max. Plug back in here to find your y is 187.5. Number 13, fencing 1.5 million square feet in area. He's dividing it in half, so you got 3 x's and 2 y's equals your y. And you know x times y equals 1.5 million, so y equals 1.5 million over x. So you plug that in for y, and now you got something in terms of x only, and you can take the first derivative, and you get this guy, you set it equal to 0, and solve, and you get x equals 1,000. 1,000 is your absolute minimum amount of fence you need. And when x is 1,000, you plug this in here, and you get y is 1,500. Same idea here, it's just the cost is a little bit different. It costs $20 per foot, and it's y feet and x feet here. But this side is you only have to pay half of the cost, so it's 1/2 of 20x. And over on this side, it's 20x completely, no cutting it in half, and 20 of the y. So you add all that up, and that equals your $5,000 the farmer has to spend. And you can solve this for y and plug it into the area formula. Take the first derivative, set it equal to 0, and you get this number here. And if you take the second derivative, it lets you know that that has to be a max because your second derivative is always negative. Alright, so this is a max, and you plug it into the y to find the y value as well. 19. 1,200 square centimeters of material to make a box with a square base and an open top. So you got 4 sides, and you got the square base. So here's your base, and here's your 4 sides, and there's no top. And so that is going to add up to 1,200 square centimeters of material. You can solve this for h, and then plug it into the volume formula. The volume is base times height in this case. And you plug that in for h, and now you've got a formula in terms of b only. When you take the first derivative and set it equals 0, you get b equals 20. And you do find that that is a maximum. Once you find b is 20, you can back substitute and find h is 10. And your volume is 4,000. Same idea here. They say the length is twice the width, and the amount of material is 10. About $10 for the base and $6 for the sides. Alright, so you say volume equals 10, and we know that the length is twice the width. Okay, so you got 2w squared times h equals 10. So you can solve for h. And now the cost is going to be 10 times the base plus 6 times each of the 2 sides. And that gives you this guy here. And now when you take when you plug in for h, 5 over w squared here, you get this formula here. And now when you take the first derivative and set it equals 0, you get cube root of 4.5. And when you plug that in, you can figure out what w is. That is w. Then you figure out what 2w is and what h is. And you can know what the cost will be, $163.54. 23, they're talking about a specific length the post office uses. It's this length plus the length around the width of your shape. So you got these 4 side lengths plus the total length there. So if you let each of these sides to be y and this to be x, you've got 4y plus x equals 108. So you can solve this for x, and then you plug that into the volume. We know the volume is x times y times y. And so you throw this into the volume, and you multiply it out and take the derivative, set it equal to 0, and your one real critical number that has meaning is 18. And you find out it is a maximum, and to plug it in and find the y, you get y is 36, so your dimensions are 18 by 18 by 36. 25, find the point on the line that's closest to the origin, so you're taking the different distance between 0, 0 and x, and normally you'd say y, but we know what y equals, it's 2x plus 3. So you can do the distance formula here, and when you square everything you get this guy here, and you can square both sides like we did before, and you still are able to get the right answer. And now when you take the derivative you get 10x plus 12, or x equals negative 1.2. If you take the second derivative, it's always positive, so that has to be a minimum. So you got a minimum at negative 1.2, and you plug that in and figure out what y is. Y is 0.6. 27, find one or several points that are the farthest away from the point 1, 0. And so you're going to have one that's in quadrant 2 and one that's in quadrant 3. So you take the distance between any random point and 1, 0, and you square both sides. Okay, and then you multiply that out. Okay, and now in place of y you put in what y equals, because we have this equation for the ellipse, and we know that y squared equals x4 minus 4x squared. So you put that in for y squared, and when you take the first derivative and set it equal to 0, you get minus 1/3. If you take the second derivative, you get a negative, which means this guy is a maximum. Alright, so when you plug in negative 1/3 into the original function, you get 16 over 3. Right? So x equals minus 1/3, and your distance is the square root of 16 over 3. You plug this in for x here, and you figure out what y is. Y is plus and minus 4 root 2 over 3. So you've got your x coordinate is negative 1/3, and your y coordinate is plus or minus that number there. This one, I'm not really sure if I left this one on the assignment. I might have deleted it. I'm not sure. If it is on the assignment, it's the last question. But they ask you to find the largest rectangle inscribed in this equilateral triangle. So equilateral triangle, all three sides are length L. Now how did they figure out that this height here is square root of 3 over 2L? Well, you know that if you draw a right triangle down the middle, you got 1/2 L here, and you got L on this length here. And when you call this guy H and use Pythagoras and solve for H, you get this guy. That's how we get that this guy right here is the square root of 3 over 2L. So we're looking at this triangle here with square root of 3 over 2L and 1/2 L, or L over 2. And if you look at the smaller triangle here, this guy here, this is square root of 3 over 2L minus y, and this guy is just x. And so you got these two similar triangles, so you can set up this side over this side is the same thing as this side over this side. And when you reduce this guy down by multiplying top and bottom by 2 and divide top and bottom by L, you end up with just the square root of 3, square root of 3. That's all you end up with. So this thing equals square root of 3. And if you write that over 1 and cross multiply, you get to here. Solving it for y, you get this guy here. And you can write it as one fraction or however you want to write it, but that's your y area there. Right? So we know what y is, we know what x is now. So the area of the rectangle is 2x times y. And we know what y is. It's square root of 3 over 2 L minus 2x. And when you multiply this out, and then you take the first derivative and set it equal to 0, you get x equals 1 over 4 L. And that's where you're going to end up with a maximum area if x equals 1/4 L. If you check the endpoints of 0 and L over 2, you get 0 for both those. So the endpoints give you 0. That means x equals 1/4 L is your maximum. And when you plug that in for your definition of y, you end up with y equals square root of 3 over 4L. So here are your two dimensions of your maximized rectangle with